The pesticide residue has been the most demandable test all over the world, especially for fruits and vegetables. This video is developed to show you the details about the sample preparation for pesticide residue analysis of vegetable sample. This process involves the following 3 steps: pesticide residue extraction, column setup, and conditioning and cleanup of the extract. For this method of sample preparation, we need a balance machine, hot air oven, rotary evaporator, blender machine, vortex mixer, glass column, glass owl, syringe with filter, desiccator, chopping board, beaker, conical flask, glass dish, separating funnel, Higson, diethyl ether, sodium sulfate anhydrous, and activated fluorosil. Let's prepare sample for pesticide residue analysis. Among vegetables, we choose tomato sample for preparation. Take some homogeneous portion of test sample and chop into small pieces with a clean knife. Crush and blend the sample using a blender to make it paste. Now take 20 grams of pest sample into a separating funnel. Add 30 ml of N-hexane into the funnel and shake for 2 minutes. Allow the funnel stand for 10 minutes for the separation of layers. Collect the upper hexane layer into a clean beaker with the aid of a pipette. Add 30 ml of N-hexane again into the separating funnel and shake for 2 minutes. Allow the funnel stand for 10 minutes for the separation of layers. Collect the hexane layer as done before and combine with the previous extract. Add 30 ml of N-hexane again into the separating funnel and shake for 2 minutes. Allow the funnel stand for 10 minutes for the separation of layers. In the same way, collect the third portion of the hexane extract and combine together. Concentrate the sample extract to about 10 to 20 ml using rotary evaporator prior to cleanup. Let's prepare the rotary evaporator for drying the extract. This is the vacuum controller, and this is the vacuum pump. We are connecting the pump with the controller unit. Now connect the rotary evaporator with the vacuum controller. Let's concentrate the extract volume to 10 to 20 ml. Transfer the sample extract into the round bottom flask. Attach the flask to the rotary evaporator. Turn the power on of the vacuum controller unit. Turn on the pump. Set the pressure at proper point. In this case, 200 ml is enough. But if you are not sure about the best vacuum level of the sample, you can use ROCKER Pilot 100's auto evaporation detect function. It can automatically detect the vapor and hold the vacuum at optimum level to prevent bumping. Tap the start button of the controller to control the pressure of the rotary evaporator at 200 ml. The vacuum controller is adjusting the pressure of the rotary evaporator. Turn on the rotary evaporator unit. Evaporation is started and the sample extract is being concentrated. Rotary evaporator should be connected with a vacuum controller unit and a vacuum pump to control its internal pressure accurately and efficiently. Proper controlling of pressure is necessary to collect the final extract without any loss. Proper controlling of pressure can be ensured by using the setup of ROCKER scientific equipment. Tap on stop button to stop controlling the pressure and long tap on vent button to release the pressure. Turn off the power of the vacuum pump. Turn off the rotary evaporator unit. Detach the flask from the rotary evaporator. Transfer the concentrated extract again to the beaker. Transfer quantitatively, washing with hexane. In the next step, we will use the USEPA 3620C fluorosil method for the cleanup of the sample extract. In this step, we will prepare a column for the cleanup for the collected extract. Take an amount of sodium sulfate anhydrous in another glass dish. Take about 25 grams of fluorosil in a glass dish, loosely covered with aluminum foil. Use activated fluorosil R PR grade. Heat the fluorosil and sodium sulfate in an oven at 130 degrees Celsius overnight to remove the moisture content. Cool the fluorosil and sodium sulfate in a desiccator before use. Take a clean glass burette. Take some glass wool and fold it. Insert the glass wool and pack in the bottom of the burette with the help of long glass rod. Now fix the burette with a stand. Add about 5 ml hexane into the burette. Take weight of 20 grams dried fluorosil. Now, add an amount of the fluorosil slowly into the column or burette. Settle the fluorosil by tapping the column so that fluorosil sprayed and settle homogeneously in the column. Add fluorosil again into the column or burette and settle the fluorosil by tapping the column again. In this way, fill the column with 20 grams of fluorosil. We have to ensure that no gap or air is trapped inside the fluorosil particles. This part is very important for proper cleanup and to increase the analyte recovery. Now elute about 60 ml of hexane to wash the column. Stop the hexane flow just prior to exposure of the fluorosil upper end to air. Discard the collected hexane. The column is completely ready to use in the cleanup process. Prepare a collection flask using a funnel and Whatman filter paper. Bring the dried sodium sulfate anhydrous and keep an amount of it on the filter paper. Place the collection flask under the column. Now, we will clean the sample extract using the newly prepared column. Quantitatively transfer the sample extract into the column. Drain the extract through the column until the fluorosil upper layer is nearly exposed. Stop the column flow when the fluorosil upper layer is nearly exposed to air. Now, prepare 100 ml of ethyl ether and hexane, 6:94 mixture. Elute the column with this ether to hexane mixture using a drip rate of about 5 ml per minute. Collect the elute in the same collection flask in the same ways as extract collection. Stop the column flow when the fluorosil upper layer is nearly exposed to air. Prepare 100 ml of ethyl ether and hexane, 15:85 mixture. Elute the column with this ether to hexane mixture and collect into the collection flask. Stop the column flow when the fluorosil upper layer is nearly exposed to air. In the same way, perform a third elution using 100 ml of diethyl ether and hexane, 50:50 mixture. Stop the column flow when the fluorosil upper layer is nearly exposed to air. Perform a final elution with 100 ml of 100% ethyl ether, collecting the elute in the same collection flask. Collect the cleaned extract into the collection flask passing through the sodium sulfate. This type of filtration is done to remove any trace moisture present in the cleaned extract. Stop the column flow when the fluorosil upper layer is nearly exposed to air. You can see the upper portion of fluorosil layer has turned into dark. This is because of the excessive accumulation of the pigments. Evaporate the combined extract elute mixture to dryness using rotary evaporator. Transfer the cleaned extract to a round bottom flask. Attach the flask to the rotary evaporator. Turn on the rotary evaporator unit. Turn on the pump. Set the pressure at proper point. In this case, 200 millibar is enough. But still, if you are not sure, you can always use pilot 100 to help you detect and hold the vacuum at best level. Evaporation is started. Rotary evaporator should be connected with a vacuum controller unit and a vacuum pump to control its internal pressure accurately and efficiently. Proper controlling of pressure is necessary to collect the final extract without any loss. Proper controlling of pressure can be ensured by using the setup of ROCKER scientific equipment. Solvent is evaporated completely from the flask. Tap on stop button to stop controlling the pressure and long tap on vent button to release the pressure. Turn off the rotary evaporator setup. Detach the flask from the rotary evaporator. You can see that no solvent is left in the flask. Add about 9 ml of hexane to the flask. Shake and rotate the flask to resolve the dried extract in hexane. It is necessary to shake well the flask for a long time to collect the pesticide quantitatively. Dissolve the residue with hexane and collect into a volumetric flask to make the volume of 10 ml. Transfer the dissolved extract into a 10 ml volumetric flask. Make the final extract volume at 10 ml. Dilution factor of this sample preparation is 2, so we need to multiply the instrumental result by 2 to get the final result. Now filter the extract with 0.22 micrometer syringe filtration system and collect into a GC vial. Inject 1 microliter of the extract into the GC system and analyze for the quantification of pesticide residues. Thanks for watching the video.